And you get x is 0. Hey, that's your only solution. X is 0. And let's check the answer. If I plug 0 in for x, is it 0? Yeah, checks out. Okay, so we should have one x-intercept. It should happen at 0. Is 0 in our domain? Yeah, we could. I don't know why I didn't put this. This was equal 0. This is my fault. That's we can have a square root of 0, can't we? You just cannot have it in the denominator. So that's my oversight there. That means we need to have brackets here. So x equals 0 is the only solution to this. All right, so what we know is this. The picture of this graph only appears in this interval, right? And we know that it has an x-intercept at 0. That's what we know so far. Now let's bring in the calculus. Let's figure out where this function goes up. Let's figure out where it goes down. Let's figure out where it's smiling. Let's figure out where it's frowning. Let me add something to what I said, because I know what I said just a second ago was probably kind of demoralizing. I'm not trying to demoralize you. When I was in calculus, my algebra was not rock solid, okay? It got better. My algebra got better when I started tutoring, okay? When I started tutoring, that's when my algebra became great. Because when you have to teach it to somebody else, that's when you have to understand it. And that's when all the holes started to fill in. So I always recommend to any STEM major, if you can somehow find yourself in a tutoring environment, it could really help your algebra. Really, really help it. All right, so the calculus. I want to figure out where's this function going up and down. I need a derivative, don't I? Oh, so now the derivative's not as clean, right? How do you take derivative of that function? These two separate, right? Okay, what's the derivative of the square root of something? 1 over 2 square roots of that something. Chain rule. Times derivative what was inside the root? 2x plus 1. Okay, are we done taking derivative of the square root part? The square root part. The square root, yes? Okay, so now separate from that, minus x, take derivative of that, you get minus 1. Let's clean it up. Why should I even try and clean it up? Well, two reasons. I'm going to have to set that equal to 0, and I'm going to have to take the derivative again, right? So let me try and get it cleaned up before I do that. Okay, all I did there was just push that up on top. Can I cancel these 2's? No, I need the 2 here as well, right? Or factor 2 out of the top and cancel, which we can't. So it sits just as it is. That's the way it is. That's my derivative. What would y'all like to do? Would y'all like to go try and set that equal to 0 right now? Or do you want to take the derivative of this? So we can either go get the second derivative now, or we can do that later. What would y'all like? You want to do it now? Okay, let's do it now. So if I take derivative of this, second derivative, right? I can do these separately because there's subtraction between the two. So I'm going to ignore that completely, because when I take derivative of that, it's going to be 0. All I'm really focusing my attention on then is this. How do I take derivative of this? Quotient rule, right? Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. All that stuff, right? What is the derivative of the top? 2. Oh, that's not so bad. 2 times the bottom. 2 root x squared plus x, right? So that's derivative of the top is 2 times the bottom, which is that, minus. Now, the derivative of the bottom. Let's do that on the side. I'm trying to take the derivative of this, right? That's the bottom. What's the derivative of that? So 2 comes for the ride. That's a constant, just bring it with you. What's the derivative of the root? 1 over 2 root x squared plus x times 2x plus 1. It's a broken record, right? We did that a second ago. It's the same thing, wasn't it? That's chain rule. We can now, on this one, cancel the 2's. Right, that 2 out front and that 1/2, the 2 on the bottom can cancel. So this is just 2x plus 1 over square root of x squared plus x. Let's come back over here. Derivative of the top times the bottom minus the derivative of the bottom, which is that. What else? Times the what? The top. What's the top? 2x plus 1. Am I done? All over this whole thing here squared. And since there's multiplication here, you can square each one. What's 2 squared? 4. And what happens when you square the square root? You just get the x squared plus x, right? But you do need it in parentheses because that 4 will distribute through. There is our second derivative. Yuck, right? Yuck. This problem came right out of the book, so y'all can see I'm not like trying to make a hard problem for you. This is the level of what the book wants you to do. See, things get a lot crazier when they're not polynomials, right? When they're polynomials, life's good. Derivatives are easy. Everything works out nice. But when you give me something that's not a polynomial function, something crazy like this, then everything becomes complicated. But we actually can do it. Well, as long as we can do the math, we can get to the result. First and second derivative, wow, this is intimidating as hell, right? I mean, this is really intimidating that we have to set that equal to 0, right? And figure out where it doesn't exist. But we'll get to that. Let's start with this one, which is now looks much less intimidating than that one, right? So let's do this one. So I'd like to know now, where's the first derivative equal to 0? Where's the first derivative not exist? All right, let's tackle the equal 0 first. I'm going to take the first derivative. And set it equal to 0. Remember, the first derivative had that minus 1 in there, didn't it? I have to account for that. What has been that thing that I've been doing every time I'm trying to set something equal to 0 and I have fractions involved? We're trying to focus on the top, right? But we have to have everything together as one fraction before we can do that. And right now I don't have one fraction. I have a fraction here and then this number right here. You cannot move this to the other side because then it's not 0 and then that rule doesn't work. So unfortunately for us, here's what I have to do. There's kind of no way around this. Sorry. Y'all tell me what I just did. Common denominator. I rewrote this 1 as that. That way they both have the same denominator. And now I can put them together, can't I? So if I put these together, it now becomes 2x plus 1 minus 2 times square root of x squared plus x all over 2 square root of x squared plus x equals 0. Y'all see it? Now can I just set the top equal to 0? Yes? Let's do that. I'm going to keep this here because I need to come back to this later. So I'm going to now set the top of this equal to 0. And if I set the top of this equal to 0, what are we looking at? What type of equation is this? Didn't we do one of these just a minute ago, something like this? This is a square root equation, and what's the technique to solve this? So get the root by itself, right? Get the square root on one side of the equation. So I'm going to take this, because it's negative, I'm going to move it to the other side and make it positive. I have to bring the 2 with it. Who has questions? I see a lot of eyes still over here, so do we have? I'm sorry, say again? This right here, right, is a fraction that is equal to 0. And we've said in the past that anytime we have a fraction equal to 0, we only have to look at when the top is equal to 0. Okay, so that's what I'm doing on this line. Then we move this over, and now at this point, I'm going to square both sides. I'm going to square both sides right now. I'll do it in blue. When I square the left, I have to do 2x plus 1 times 2x plus 1, and I have to FOIL that. I don't just square each one, right? I have to actually FOIL. I'm going to do that in my head, but you could do that on the side, yes? Okay, it would be 4x squared plus 4x plus 1. You get 3 terms if you square this out. Over here on this side, you square this because it's multiplication. You square each one. So you square the 2, it gives you a 4. And then you square the square root, it goes away, but you still have the parentheses. And when you look at that, can you all tell what type of equation this is going to wind up being? What type of equation is this? It's looking quadratic, isn't it? That's quadratic. This side's over here is quadratic. But I think a bunch of stuff cancels again. Let's see. This is 4x squared plus 4x plus 1 equals 4x squared plus 4x. Holy crap. What do we get? 1 what?
1 equals 0.
1 equals 0. Right, because can't you cancel the 4x squareds on both sides? Can't you cancel the 4x's on both sides? And aren't you left with 1 equals 0? And aren't you sitting there going, what the hell does that mean? What do you think this means? We've not seen this before. What do you think this means? We were asking ourselves, when is the derivative 0, right? That's what we were asking. When is the derivative 0? What is this telling us? It's never 0. It's never 0. That's what this is telling us. Because when we try and set it equal to 0, we get something that doesn't make sense. You following me? So if it's never 0, then it never flattens out, does it?
So it never curved? Yeah.
Well, we don't know. It could cusp, couldn't it? It could cusp. And because when you have a cusp, your derivative doesn't exist. We haven't looked at that yet. We have to look at where the derivative doesn't exist. After that, we'll be able to draw some conclusions. But right now, what we know is that the derivative, this equals 0, this never happens. All right? So far, there are no critical numbers. So far, no critical numbers. All right? Now, I need to know, where does the derivative not exist? So I'm going to go back to our derivative. I don't know. Let's look at this one right here. The one that we set equal to 0 when we got them all together into one fraction. What would cause this to have a problem? Well, if that right there, right, or this underneath, if we ever had any domain issues with that, right? Will we ever have a domain issue with any of these? We will, but remember, we've already restricted our domain, haven't we? We've restricted our domain to make sure that this thing never had any issues, right? But there's one value of x I can't have here that I can have there. What is it? 0. 0. See here, 0 is okay, right? 0 here, square root of 0, 0. But is 0 okay here? No, you can do square root of 0, but then you're dividing by 0, right? So the only critical number you have here is x equals 0. It causes division by 0 on the derivative. All right. I know this is confusing, but let me continue. All right. I'm going to keep my second derivative. We haven't even started the second derivative yet, right? Everything we've done is just the first derivative. So I need to draw my conclusion now. On a number line, I have x equals 0, right? That's the only critical number I have. And I need to pick test points. But my interval that I'm allowed to look at, right? I'm only allowed to look from 0 to the right. I can only pick test points here, and then also -1 this way here. I have to be very careful how I pick my test points. So I'm going to pick something here, and I'm going to pick something here, because I need to know what's going on over here. Is the function going up or down? I don't know. So how about test point? Let's go with 1, because that's a nice number. And over here, let's go with -2. And where are those getting plugged in? To the derivative that I just erased. I would never give you a problem like this on a test. I'm just letting you all know that, okay? But this, again, is a problem right out of the book, out of this section on sketching. So, again, this is the level of problem the author would expect that you could handle. All the algebra, all the different techniques in here. All right, I erased the derivative. So somebody remind me, what was that derivative when we cleaned it up and set it equal to 0? Plus 1? No, when we put it together. We had this on the bottom, right? And then this on top. Was this the right numerator or no? That's the right thing? Yeah, okay, yeah, it's the top over there. There you go. Yeah, that's it. Right? This was our derivative. Take out the 0. That's our derivative. We're going to plug -2 into this. And then we got to plug 1 into this. What can y'all tell me? What can y'all tell me about the denominator here? No matter what number you ever plug in for x, this square root here, this would have to be a positive number in here, wouldn't it? That would have to be positive, or else I couldn't take a square root. And what's the square root of a positive number? Positive, and then times 2. So the denominator is always positive, no matter what. So really, all we care about is what happens to this when we plug in these two numbers. So let's plug -2 into the top of this. I'm going to just do it up here. This is 2 times -2 plus 1 minus 2. And then I'm doing -2 squared is 4 plus -2. Not obvious yet. -4, that's those two together, plus 1 minus 2 times square root of 2. We've got a negative number here. This is a negative number. That means over here your function's going down. And then if I plug 1 into the top of this, let me go ahead and do it. I'm going to get 2 times 1 plus 1 minus 2 times root 2. 3, 2 root 2. That should be positive. Pretty sure it's positive. Our function goes up. Well, one way I could check this real quick is to see it with the graph, right? I'm going to graph this now so we can at least start seeing what's happening. There's this still silence in here that's concerning. All right, that's what the graph looks like. All right, kind of weird looking, yes. Does it look like at -1, to the left of -1, does it look like it's going down? Decreasing, yes? And then to the right of 0, here's 0. To the right of 0, does it look like it's going up? Yeah. So increasing to the right of 0, decreasing to the left of -1. Now we have to do the exact same thing for the second derivative. Oh, I should ask, do we have a local max or min? So do you ever see the graph go up and then down? No, it's no max. Do you see it go down and up? Yeah, but not really. It goes down, right? But then the graph like jumps, right? And then it starts going up again. That's not going to be a local max. I mean, sorry, local min. We need for a local min, it needs to go down and back up at a point, right? Not over some gap in the function. Okay, we've got about 15 minutes. You think we can get this second derivative set equal to 0? You think we can do it? We're going to try. I'm erasing all of this because it just is cluttering my mind to have it up here. All right, I want that right there, second derivative, I want that set equal to 0. The good news is that the bottom, it's already one fraction, right? So I can just set this top equal to 0 right now. Right? I can just do that. So the second derivative being equal to 0 really just means that, let's see, that's a 4. 4 root x squared plus x minus 2x plus 1 over square root of x squared plus x. I need to set that equal to 0. So setting the second derivative equal to 0 really means setting just the top equal to 0, which is what we got there. And now, how am I going to solve that? There's a couple of different ways. Anybody see anything?
You might have erased part of the second derivative. Because I got at the end after 2x plus 1.
Oh, there's something more? Oh, there was another 2x plus 1 here, wasn't there? Oh, well, no, it was here. I just squared it here, sorry. Yeah, sorry, I must have erased it on accident. There was another 2x plus 1 here. It was that and then this. So that just slided up there, and now it's 2x plus 1 squared up there. We're still safe. Thank you for pointing that out, because that would have been a problem later. All right, how do you want to do this? You want to put everything together again? Yeah, let's do that. Common denominator. So that means look at this as being over 1, and then combine them, which means I have to multiply the top and bottom here by square root of x squared plus x, square root of x squared plus x. It's not as bad as it looks. Like, it's going to actually clean up pretty nice here, all right? So it looks terrible, but if you just trust your algebra and take your time, things are going to work out, all right? So when I do this, if I combine this together, right, aren't those two roots going to go together, these two roots, and just basically go away? And you still have a 4 sitting in front? So I have a 4 sitting in front of x squared plus x. All right, and then minus, then this numerator, 2x plus 1 squared. But then all of that over my common denominator, which is square root of x squared plus x. And I'm seeing when that's 0, right? Any questions? Yes?
Isn't that the same 2 we had earlier, where it was 4x squared plus 4x, and then 4x squared plus 4x minus, like, plus 1?
I don't remember what we had earlier. It might be. I don't.
Yeah.
It's the second derivative. It should be a little bit different. I don't. Did we have this squared? I'd have to go back and look. Yeah. We'll see if it comes out to be like no solution again, right? It might come out to be like, hey, there's no solution here. So let me. What am I going to do now? Don't I have a fraction equal 0 again? So I can just set the top equal to 0. Again, for the second time. And now let's just do this. Distribute through 4x squared plus 4x, and then minus. Now here, I'm going to expand that. Again, I'm going to do that in my head. 4x squared plus 4x plus 1. Yeah, it's the same thing, is it? Was it negative 1 equals 0?
Yeah.
It was?
Or it was
Yeah.
1 equals 0, yeah,
It was 1. It was a little different.
a little bit.
Okay, so what happens here is you distribute the negative through, and you wind up getting negative 1 equals 0, which isn't true. Which means we have no solution again. Right? Where does the second derivative not exist? Will we ever have any problems with this second derivative? Will we ever have problems?
At 0.
At 0 again, exactly like we did with the first derivative. So x equals 0 is the only issue we would have. So now I'm going to do the same thing, do a number line. I'm going to plug in, let's see, 0 here. And I'm going to remember that I have to go this way. And then what was it, negative 1? This way. Pick test points. I'll do the same 2 test points, negative 2 and positive 1. But this time they're getting plugged into the what? Second derivative. And they're both going to come out to be negative. I'm not going to do it, but they should both be negative. How do I know that? I looked at the picture, right? Did you look at the picture? Right? When I graphed this earlier, do you all see that this is always concave down? Always part of a frown. And over here, this is part of a frown as well. And how do I know it doesn't ever change? Well, because whatever I pick here, it's always going to be doing here, right? And then whatever I pick here, it's always going to be doing that over here. So it's got to be negative and negative from that picture. All right, so I'm not showing that. All right, what time is it? Yeah, that took us the rest of class. And I didn't even finish because all I've done is I've put this together. We haven't drawn the picture of the graph yet. There's another part of this problem where we put all the information together and we graph it by hand. All right, so what do I want you to do, right? What do I want you to do? I want you to try and do the homework from 4 point. I want you to try and do the homework from 4.3, okay? And the 4.3 is, up, down, concavity. And then from 4.4, which is graphing, like doing this curve sketching by hand, I don't want you to do the curve sketching by hand. But I do want you to go to the book. This is for 4.4 exercises. And I want you to look at the first 6 problems. These first 6 problems right here. And these are on the ebook. But those first 6 right there, do not follow the directions here and try and sketch these. What I want you to do for these first 6 is figure out where the function goes up, where it goes down, where it's concave up, where it's concave down. Up, where it's concave down. So like what we were doing before we did the sketching, before that, those examples we did, parts A, B, C, and D, try and do that for these 6. All right? I think you would agree those functions are pretty straightforward, right? Polynomials. So that's going to be more in line with what you'd see on a final exam. Will be something where you're just showing me you know what to do, and you're not getting bogged down with all the algebra, right? So the functions are more straightforward. Okay, everyone, have a good rest of your day. Tests are up here. Let me turn my camera off.